Good day, class. My name is Engineer Joshua Ilariwa, and today we're going to be looking at a module that has to do with electrical control and protective devices. Electrical control and protective device. In this module, we should be able to talk about the control, what are protective electrical devices. We'll be looking at different control and protective devices. And we should be able to identify, maintain, control, and protective devices. And of course, the usage and the troubleshooting of these devices. In lesson 1 of this topic, we're going to be looking at types. What are types of an application of control devices? First, we'll be looking at two: control as a device, control devices. Then secondly, we looked at protective devices, control and protective devices. What are the types? The types and the application. As well as in the protective device, we should be looking at the types and application. So, as we progresses, we looked at control. What is control devices? What do you understand as control devices? An electrical control devices system is a physical interconnection of devices that influences the behavior of other devices or systems. Control devices are used, basically, control devices. Basically, is for what? On and off. On and off systems. On and off system or operation. On and off. When you talk about on and off operations, that is what control devices is all about. You turn off current flow. This helps in turning off the current flow in the system. When a current is passing through a medium like cable, you have the devices connected to it to either turn off or on, like switch, a normal switch. So that process of operation is referred to as what? Control. It's either turn on or what? Turn off. Why protective devices? As it is here, protection. As the name implies, is what? Protection. Protection is a device or equipment applied to electric circuit or power system to determine what? Abnormal and intolerable what? Conditions. That is to say, it initiates appropriate what? Corrective actions. These devices include like what? You have lightning arresters, you'll have power surge, fuse, relays, and all that. The trips, process or operation of what? Tripping, a cut off from the system in case of what? Abnormalities in the electrical what? System. What are these types of control devices? First, let's look at the types and uses of what? Control devices. Basically, we're going to be looking at what? The types here can be one, switch. We say switch is what? The control devices. Contactor. Contactor is another what? Control devices. Switch is the most common. The switch there is the most common circuit control devices. Switches normally have two or more sets of what? Contacts. You have the opening, which can be referred to as what? Either make or break. On or off operations. This is when it results to what? Circuit. From the materials, you'll be seeing different symbols and types of different circuits. We have circuits that has to do with single pole, single throw. Circuit that has to do with single pole, simple throw. Also, we have, which is just basically types of control switch, what we refer to as SP, single pole, single throw. That's the simplest form of what? A switch. You see more types of switch when you go to the materials. The material that is given, you see different types of switches. We have single pole, double throw. We have double pole, single throw. As in the case, this is what? Single pole, double throw. We have single pole, double what? Throw. We have double pole, double throw. It depends on. So we looked at first the switch. Like I said, switch is just the simplest form. We have a switch that's like oscillator switches, different type of switches. We have oscillator switches. Then what are the common faults that can be encountered when it comes to switch, like that of the oscillator? Basically, the switch, the fuse, which is a protective device, though, but in an oscillator, you still have switch a fuse in the switch. So that is why common fault can be what? The fuse. The fuse can burn or blow. Depends on what you observe. So definitely you have to check, troubleshoot check for continuity using a multimeter. I think we're going to, subsequent lessons, we're going to be looking at use of what? A multimeter, identifying a multimeter and how to use a multimeter. You understand better on its application. If a switch is faulty, you should be able to start checking, especially when it has to do with isolation switch, from the fuse itself. Then we looked at normal push button that you can have. Even your remote, you can just push buttons and all. There are some push buttons that has this retaining contact. When you push, it retains its operation. Then you push again, it releases to another operation. So these are control devices. You see more in the material given, where you talked about different types of switches and its operations. Then we looked at contactor. Contactor, basically, in some cases, they can refer it to as what? Another protective or what? Control. But basically, according to IE regulations, contactor is an electrically controlled switch used for switching an electrical power what? Circuit. Of course, in a contactor, it has a lot of contacts. It's either make or break as well. Contactor either make or break as well. That is why it's referred to as what? Switch. So it has contacts. It has contacts, basically normally open contacts. So once it is energized, it automatically closes the circuit. That is, it makes the circuit current, allow current to flow through. But once it is in a break situation, it's automatically open the circuit. In the case of maybe where there is a fault, it opens. And once it opens, current will not be able to flow. So basically, you see it as a contactor is equipment or a component who simply has a coil. From the coil, it goes gradually because it's symmetrically the same time it goes. The coil here is referred to as what? A1, A2. Like I said, we can have different contacts. You see some, basically the major is the 4 contacts. The 4 contacts here you have, that is at the contacts. Then, of course, basically this is the words, the 3 contacts for normally the 3-phase system, as stated in the different type of power supply that you have might have undergone in other classes. This now comes to be the what? It can be auxiliary, refers to as this, then on its own. It comes this way. Normally, basically, as manufacturer designs, this is 1, 2, 3, 4, 5, 6. Basically, this is usually 13, 14. That is auxiliary contact. This is the inbuilt, the symbol for what? A contactor. This is the coil. This is the coil. Once this coil is energized, it closes the contact. Once the coil is energized, it closes the contact. Once this key is closed, it allows power to flow through from the input to the output. So basically, that is the symbol of what? The contactor. So you see more of that in the material details of what? The contactor. Basic problems that the contactor encounter can be in the coil. Basically, the coil, maybe when the voltage is not enough to power the contactor, because it has different sizes of voltage from 240 volts, from 24 volts, sorry, to 240 volts supply. You can have it in different sizes. Occasionally, you can get 480 volts supply, which it operates on. And of course, we looked at the contactor coil, which is very, very, because of the rush flow, current flow, tripping, and all that, you can have problem of the contact not properly what? Close, fit to allow current to flow through it. So with regular maintenance, you can as well be able to take care of your contactor to last for long. So basically, we looked at what? Switch, contactor, and the relays. Of course, 3 is relays. Relays are control devices. We look at relay as a control devices. Relay. We have relay in different types. It's an electrically operated switch used as what? Electromagnets to manually. It can be manually operated, but operating principles are also used, such as what? The solid state form. You can have your television remote in your houses. Television remote. Once you point your remote to the television, it's with the help of what? An LED device. It senses. That is control. You are controlling, switching from one channel to another. So those kind of relays that does the operation in the remote is referred to as what? Solid state relays. Of course, they have other relays that are physically operated, like used in the electrical connections. So relay 2 has contacts. We have, this is what? Normally open contact. And we have a contact as well that is closed. We refer to them as what? Normally closed contact. We have sizes too of relays, depends on the operations. Relay also has contacts, issues of contact when it is like tripping on, off operation. It can affect for a long time. So you have to still check for relays to maintain relay regularly. So basically, relay also has what? A coil in it. So you see it in the material when details. So it has a coil in it also. When it energizes, the trigger is what? Is operation. So relay is similar, but it's just that contactors are for heavy duty equipment. Relays is for what? Smaller sizes operations. And of course, we have what we refer to as what? Overload relay. Overload relay. What is this overload relay? That is the fourth type, overload relay. Overload relay, in some materials, they can like refer to it as what? A protective device, because it's the most sensitive components in an electrical what? Circuit. Overload relay, I said, is the most sensitive component. Also known in some materials, they can refer to it as what? Overload release. Overload release. What we mean by that word when he said overload release? Overload release. Because it releases, it isolates that part of the component. It doesn't allow fault to pass through. If a fault passes through from the mains and goes through contactor, maybe a sharp a fault penetrates through the contactor, the overload relay will definitely arrest it when connected in a circuit. So that is why we refer to the overload relay or release, as the names imply, as the most sensitive part that protects what? The electric motor. Basically, you will see that when we are talking about industrial electrical installation, when you see how motor runs and the connections of all that, you will understand more the importance or the uses of overload relays. So the diagrams are available in the materials, which you can make reference to anytime. So we have different adjustable what? Settings. It has an adjustable settings, overload protection with phase loss sensitivity, automatic or manual reset, seal though. You see everything in the material that will be given. So of course it has contacts also like other relay. So definitely these are basically types of control devices that we're looking at in this class today. Thank you. And of course, I know that in the next class, when we'll be looking at the types of protective devices, we're going to understand more the differences in all these relays. So I know from what we have discussed, we looked at control devices, we looked at protective devices, and I've referred us to the materials where you have detailed explanation of these lessons. Then we looked at what are control devices, types of control devices and its uses. We have understood that a switch is a protective device, contactor is a protective device, relays, and what? The overload relays. So in subsequent lessons, we should be looking at the types and application of protective device. Thank you.